Okay, you guys, so today we're talking about arithmetic sequences. So arithmetic, that just means addition. So all of these we're just gonna be adding. Don't ever think about like multiplying or dividing. We're always gonna be using just like adding or subtracting, okay? But so basically the definition of an arithmetic sequence, it's just a list of numbers with a constant difference between the terms. So a constant difference is going to be, it's the d value. So when we're solving for it, we solve for d. But it's the constant number that's either added or subtracted between our consecutive terms. Okay? So basically, if we look at this chart down here, we have these term numbers. We can think of those as x's. Okay? So like the first term, so in spot 1 of this list of numbers, I'm going to have the term, the number, 3. So this we can kind of think of as our y's. So in the first spot, so basically if I were to list all of this out, the first spot I have a 3, the second spot I have an 8, for my third term I have a 13, and then an 18, and then a 23, and then I could keep going. So these are my terms, and then the spot that they're in, the term number, so like spot 1, spot 2, spot 3, that's just your term number, okay? So then it says, it shows that the difference between the consecutive terms is 5, because every number, I add 5 to get to the next number, because 3 plus 5, so if I add 5, 3 plus 5 is going to give me 8. Then if I add 5 to 8, I get 13. If I add 5 to 18, or 5 to 13, I would get 18, and then 23, and then what would this next number be? Jade, what do you think? Yeah, 28, because if I add 5 to 23, I'm gonna get 28. Okay, so the 6th term number, the term is gonna be 28. So I know this is like completely switching your mindset from like graphs, so we're not graphing today, so that's exciting, but something a little bit different. Okay, so let's look at these lists. So what I want to do, it says, does the list of numbers represent an arithmetic sequence? If so, what we need to find our common difference, and then we're also going to find our next 3 terms. So for this first one, I have 4.1, and then I have 6.3, and then 8.5, and then 10.7. Okay, so I have those numbers right there. So in order to figure out if this is an arithmetic sequence to answer my question, I need to figure out if my common difference is like adding or subtracting the same number. So what do you guys think? What are your thoughts? Mackenzie, what do you think? Yeah, adding by 2.2. Because if I add 2.2 from 4.1, so 4.1 plus 2.2 would give me 6.3. If I add 2.2 to 6.3, that gives me the 8.5. And then if I add the 2.2 to 10.7, or 2.2 to 8.5, it gives me the 10.7. Is everyone okay with that? So we're adding by a common difference of 2.2. So is this indeed an arithmetic sequence? Yeah, yep, it follows the rule. So yep, yes, it's an arithmetic sequence. Okay, so our common difference we said was 2.2. So we answered that question. And then the last thing, it now says I need to find the next 3 terms. So Braden, how would I do that? Okay, what would that give me? 12.9. And then what would I have? 15.1. And my last one? 17. Yeah. So to keep finding my next 3 terms, all I have to do is keep using this rule. I just need to keep adding 2.2 to the previous number to find the other numbers. So my next 3 terms would be the 12.9, the 15.1, and the 17.3. Is everyone okay with the first example? Yeah. Okay, so now this next one, we're doing the same thing, but I have the numbers. So I have the numbers 1/2, and then I have 1/4, 1/8 and 1/16. Ocean, do you think I add or subtract by the same thing every time? No, because yeah, to get from 1/2 to 1/4, what would I have to subtract? Keaton, what do you think? Yeah, 1/4. So this one, I'm subtracting 1/4. To go from 1/2 to 1/4, I subtract a fourth. And then Caden, to go from 1/4 to 1/8, what would I do? Yeah, I'm going to subtract an eighth. And then what about to get from 1/8 to 1/16? What would I do? Yeah. So are all of these the same number? Do I go by the same thing every time? No. So this one would not be an arithmetic sequence. So I don't need to find my next three terms because it doesn't follow the rules. Okay, so I would just say no. Okay, so then writing equations for sequences. So we look at kind of what's going on up here. So it says each term can be represented by f of n. So these like are functions. So it's just like y equals, but so it's f of n instead of f of x because we're using n for our term numbers. But if you write f of x, that's totally fine. Okay, so it says where n represents the term number. So basically what it's saying here, so it says, so for when our n is equal to 1, so our first term, our first spot, we have the number 3. So in the first spot, so when I have, basically when I have 1 as my x, my y is 3. So in the first spot of my sequence, I have the number 3. Okay, so then if we look at this table, so down here, when I'm looking at my second term, what I need to do is I take my first term, so what my answer was for my first term, and I add 5 to it. Okay? Then to figure out what my third term is, I take the one from my second term and I add 5 to it. And then to figure out what the number for my fourth term would be, I take the number from my third term and I add 5 to it. That makes sense. That's what we were doing up on the board, right? So then down here, the general equation for f of n is I would take my equation and I'd have n minus 1, because if I'm plugging in, like, say I'm plugging in 18 over here. So I'm trying to find my 18th term. Well, in order to figure out when I'm at spot 18, what the number is going to be, I need to figure out what spot 17 is, because I put 18 minus 1. So at spot 17, and then add 5 to it. Okay, so this is just my general equation. So you just, whatever number you're trying to figure out, you just subtract 1 from it and then add 5 to it. So you just look at the previous one, add 5 to figure out what your current number would be. Okay? So then we also have recursive definitions. So this is kind of getting us more into our formula. So a recursive definition for an arithmetic sequence, basically it just says each term is defined by operations on the previous term. So it's exactly what we've been doing. We have to know the number before, and then we add or subtract a number from that number to give me my next number. So a recursive definition, I have to know the spot before in order to figure out the next one, okay? Because it's building on that next term. So the way that we write the equation, it looks like almost a piecewise function because there's two different pieces. And so what we would write a of n is equal to a1, and the a1 is gonna be the number in the first spot. So like at spot 1, what is that number? And that's when our n is equal to 1. And then our other part of our equation, so this would be a of n minus 1 plus our common difference of our d. And this is when our n is greater than 1. And basically every time we write our recursive definition, all we have to do is we write exactly this, and all we're trying to do is substitute a number in for our a1 and our d. Other than that, I leave that alone, okay? Because it's basically how you need like an x and a y in every equation. Like you can't just plug numbers in for everything. Well, this a(n minus 1), this is like our x, okay? So I need that there. I can't change that out. Okay, so the only things when I'm plugging stuff in is I'm going to put a number right here and a number right here. A number for my A1, which is gonna be the number at the first spot, and then a number for my D, which is gonna be my common difference. So we'll do some examples. Okay, so I have this sequence, so I have 4, 7, and then 10, 13, 16. So what I'm trying to do is figure out if it's arithmetic, and then if it is, I want to write my recursive definition. So I want to write a formula for it. Okay, so looking at this, is this arithmetic? Haley Winter, what do you think?
Yes.
What do I grow by?
3.
3, yeah, so my common difference is gonna be 3, because I add 3 every time. Okay, so I know that my D value, my common difference is 3. Okay, then my A1, that's always the very first number, like spot 1, what your number is. So my A1 is gonna be 4. So then knowing those pieces of information, that's all I need to write this equation. So I'd have A of n is equal to, and I'm gonna plug in for my A1, spot 1 was 4, so I put 4 when my n is equal to 1. And then I'd put A n minus 1 plus my common difference of 3 when my n is greater than 1. So this would be my equation for this sequence here. Okay, which makes sense because if we kind of like look at the equation to give us the sequence. So if I have at the first spot, so when my n is equal to 1, at the first spot I have the number 4, which that's the case. Then at everything above spot 1, so when our n is greater than 1, so at spot 2, spot 3, spot 4, everything above 1, I use this equation right here, which would be, so if I'm trying to plug in 2, so if I have A of 2 minus 1, well 2 minus 1 would just be 1, so I have A1 plus 3, and my A1 value, we said that that was 4, so I'd have 4 plus 3, which is going to give me 7, which is my second number. Is everyone following that? Okay, so it's just 2 pieces, kind of like a piecewise function. So the first piece just gives you your first term. The second piece is an equation that you can use to figure out all of your other terms, as long as you know the one before, okay? So I can just figure out what like term 18 is, because I don't know what term 17 is. So you always have to know the one before it to figure out the next one, okay? Questions on recursive definitions? And when it says definition, sequences and series just use that word instead of an equation. So it's the same thing, like when it says find your definition, it means find your equation, okay? Okay, so then we also have an explicit definition. And personally, I think this one is a lot easier than the recursive, because this one, you don't have to know the previous term. It's just an equation. So in this one, I could figure out what term 18 is. So basically it says an explicit definition for an arithmetic sequence is gonna follow this equation right here. So AN is equal to A1 plus D and then times n minus 1. And when I'm solving this one, I also am just plugging in information for my A1 and my D. I still need this AN over here, and I still need the n, because think about it like x and y, like you need an x and a y in every equation. So we need an AN and we need the n. So basically, if I can figure out what my A1 and what my D are, I can plug it in this equation right here, and then I would have my explicit definition. And that equation, it's gonna allow you to find any term without knowing the previous term. So this one, I always had to know what the number before was, but using that equation, I can solve for, if I wanted to solve for what term 122 was, I could do it without having to figure out what all of them leading up to 122 are, okay? So that one's just gonna be, it's a little more useful just because you don't have to know everything before. But then sometimes you're gonna be given an equation where it looks like it's in the recursive form and you need to find the explicit. So we need to be able to go back and forth between the two equations. And to do this, all we have to do is know what number is our A1 and what number is our D, and then appropriately place them in the other equation, and then vice versa. So we all, like every single equation or definition, just always figure out what your A1 is, always figure out what your D is, and just plug it in where it should go, okay? So, it says I have the equation, so I have AN is equal to, and then 3 when my n is equal to 1, and then I have AN minus 1 plus 0.5 when my n is greater than 1. Okay, so looking at this right here, I know I need to figure out what my A1 is and what my n is, or D, sorry, we're not to that, D, what my D is, and then I can put them in the other equation. So Haley Berry, what do you think my A1 is? Yeah, it's 3, it's just this number right here. This is always my A1. So at spot 1, I have the number 3. So my A1 would be 3. And then Faith, what do you think for my D? What do you think my common? Yeah, 0.5. My common difference, I'm gonna be growing by 0.5. Okay, so knowing that information, if I look at what it gives me for my explicit, I have AN is equal to A1 plus D of n minus 1. So now all I need to do is plug these numbers in where they should go. So then, Cooper, what would I have for my equation if I plug everything in?
3 plus 0.5.
Yeah. So I'd have AN is equal to 3 plus 0.5 to the n minus 1. And then just to kind of see how this works, let's solve for term 7. If I plug 7 in, I would just plug, because your n is always your term number, so you'd plug it in over here. So I'd have 3 plus 0.5 times 7 minus 1. And then that's going to give me, so this is spot 7, and then it's going to solve for what that number at spot 7 would be. So if we solve this out, 7 minus 1 would give me 6. 6 times 0.5 would give me 3. So I'd have 3 plus 3, which would give me, yeah, 6. So when I'm at spot 7, my number there is going to be 6. So you can see how you can solve without using the number before. Okay, so the difference in the formulas. This one, you always have to know what the previous term was, because you have to put that number here, versus this equation, you can just solve it for any number you pick. Okay? Any questions so far? Do you guys like this stuff? Is it better than piecewise functions? I see a lot of kids said no, but everyone else said yes. Okay, so let's go ahead. This time I'm starting with an explicit formula, and I want to write the recursive. Okay? So again, all we ever have to do is figure out what our A1 and what our D are, and then plug them in where they should go. So my equation, I have AN is equal to 16 minus 3 n minus 1. So looking at this, Mackenzie, what do you think my A1 and my D are?
A1 will be 16 and then D is -3.
Yep, it's going to be -3. Yep, so you have to make sure you carry that sign with you. So if it's like minus, your D is -3. And if it's negative, that's going to mean that you're subtracting. So your sequence is going to be getting smaller. You're subtracting by the same number every time. If it's positive, you would be adding and your sequence would be getting bigger. Okay, so our D would be -3. Then if I come over, I know basically all I have to do is change these numbers. So if I look, this is my basic setup for every recursive definition. All I have to do is fill in these two blanks. So every time I go to write a recursive definition, write all of this and fill in your blanks. Okay, so Brayden, what's gonna go up on the top?
16.
Yeah, 16, because my A1 goes on the top. And what goes on the bottom, Brayden? Yeah, -3. And so then here would be my recursive definition. Okay, so just being able to go back and forth from one to the other, okay? Especially if they give you that one and then they ask you to solve for something really, really big, I would turn it into this equation, put it in your explicit form, and then you can solve from there. So that way you don't have to figure out all the numbers, okay? So if they give you the recursive, ask you to solve for something big, move it over to explicit and then figure that out. Okay, so let's go ahead, let's do a word problem. So it says a high school auditorium has 18 seats in the first row and 26 seats in the fifth row. So the number of seats in each row forms an arithmetic sequence. So every row is adding by the same number of seats. So I want to figure out my explicit definition, and then also I want to figure out how many seats are going to be in row 12. Okay, so I'm going to draw a little picture of our auditorium. Okay, so row 1 has 18 seats. So there's 18 seats in here. And then row 5 is gonna have 26 seats. So this is row 1. I'm gonna have row 2, row 3, row 4. Up here at row 5, I have 26 seats. Okay, so now I need to figure out, so I have all these rows in between. So row 2, row 3, and row 4. I need to figure out how many seats are in each of these rows. It's growing by the same number every time. Does anyone have an idea how I can figure this out?
2.
You think I'm going up by 2 every time? Yeah, Braden? Yeah. So if I go up by 2 every time, I'd have 20 here, 22 here, 24 here, 26 there. Yeah, that worked out, didn't it? So every time I'm probably adding like 1 seat on the end. It's probably like an auditorium like that. So how did you figure that out, Braden? You just went up by a certain number. You just tried different things.
Well, I tried 2 first, and it worked out.
Oh, okay. Yeah, so guess and check. So yeah, no, this one worked out for us. We grow by 2 every time. So sometimes though, we might be growing by something weird. Like what if we were growing by like 2.2? Do you think you want to have to guess and check that over and over? No, so something like this, totally fine to try different numbers, but a way we can actually solve it without having to guess and check is we know, so remember these we can say are like our spots, like our terms. So at term 1, so at A1, I have 18 seats. Is everyone okay with that? So at the first spot, I have the 18 seats. Well then at the 5th spot, so at my A5, I have 26 seats. So in my 5th spot, there's 26. Okay, so that's what I'm given right there. So then what I can do from there, so basically, I'm trying to write an explicit definition, and I'm actually going to use that to help me like solve this, okay? So, let's see, where am I at? Okay, so we know that basically we have the equation AN is equal to A1 plus D of N minus 1, right? That's our explicit definition. So my A1 is 18. I can plug that in. But without using guess and check, I didn't know what my D was. There was no way to figure that out. So I'm actually gonna solve this equation for D because I have numbers for my N and my AN. Because I have these numbers right here. So I already used my A1, so I don't wanna use that set again of like X and Y. But at my A5, so my spot 5, so when my N is 5, I can plug 5 in over here. And I know when my, like this would be my A5, since my N is 5 and now I put 5 over there. But A5 we said is 26. So I can go ahead and plug 26 in right here. So I'd have 26 is equal to 18 plus D times 5 minus 1. So now this equation is set up so that I can solve for my D value. So even though we guessed and checked and figured out what number it was, if I have something like this, where I have 2, I can think of them as almost like 2 like sets of numbers to coordinates. So I had, at spot 1, I had the number 18, and I plugged that in. And then at spot 5, so spot 5, my n is 5, I have the number 26, so I can put the 26 in there, because those go together. Is everyone okay with how I set this up? Yeah. So then if we solve it out, we're just trying to solve for our d. So to do that, 5 minus 1, Haley Berry, what does that give me? 4. Okay, so I have 4, and then these are multiplied, so I have 4d, and then 18 plus that is equal to 26. And then Haley Berry, what would I do next? Minus my 18. So 26 minus 18. What does that give me, someone?
8.
8. So I have 8 is equal to 4d. And then Brayden, what do I do?
Divide by 4.
Okay. So that gives me,
2.
yeah, so that gives me the 2 that we figured out is what number we're growing by. Okay, so if you ever just start with basically like 2 coordinates, you can do it this way where you're solving for your d. Okay, so you can't use, we couldn't use the A1 for both spots because we already used it here, so then use your other coordinate. Just put in the n and put in the an. Okay, so then when it says we just need to write our explicit definition, we pretty much already did that, so all we would have to do is change this d to a 2 that we just found. And then we need to make sure we basically have our x and y, so we would need our an and then our n. And then this would be our explicit definition right here, okay? So we need to just make sure we put the n and the an back in, okay? And then the last question, it says how many seats are in the 12th row? So to figure that out, now that we have this equation right here, we can just plug the 12 in for our n. So, if I do that, I have an is equal to 18 plus 2 times 12 minus 1. So then, Jade, walk me through these steps for how to solve this. What would I do first? Okay.
So I had 18 plus 2, and then in parentheses is 11.
Okay. And then what would I do?
And just multiply the 2 and 11.
So I'd have,
And 2.
okay,
You just add them together to get 40.
yeah, add them together and I end up with 40. So in my 12th row in my auditorium, there would be 40 seats. Any questions, you guys? Okay. All right, so then that was sequences. So now we're gonna work into series. So a sequence is the list of numbers, and series is when we're adding that list of numbers up. So basically it says the arithmetic series is the sum of the terms in an arithmetic sequence. So the sequence is all the numbers, the series is when you add them up. And then my question, it says, what's the sum of the terms of the arithmetic sequence? So I have the sequence 1, 4, 7, 10, 13. So how would I figure out what my sum of those terms is? Ocean, what do you think? Well, how would I figure out the sum of these, like, numbers?
Would just add them together.
Yeah, just add them together, exactly. So I would add 1 plus 4 plus 7 plus 10 plus 13. And then somebody go ahead and add those up for me and let me know what you get. 35. Yeah, that's what I got. So basically the general formula for how to add them up is you just add all of the terms. So the SN, so now this is like the sum. So the S stands for sum. So the SN is equal to, you add your first number, your second number, your third number, all the way up to the end. Does this seem very practical though? What if I have like 100 numbers? Does that seem fun to add 100 numbers together? No. So there's also another equation. So if it's something short, like the one we just did, you can just add them up. Simple as that. But if it's something really, really long, you have a really long sequence, or maybe you don't have all of the middle numbers, like it says like, we have these numbers and then it says dot, 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 and then it goes to 118. Well, if I have something like that, I don't know what all the middle numbers are, so I can't add them up. So instead, I can use this equation right here, where it's Sn is equal to n, and the n is gonna be how many numbers are in the sequence. So how many specific numbers. So up here I have 1 number, 2 number, 3 number, 4 number, 5 number. So the n is how many numbers are in your sequence. And then that's times our A1 plus our AN. And your A1, remember, is just the value in the first spot. And then the AN is gonna be the value of the largest number, so your last number. So your A1 is your first number in your sequence, and your AN is your last number in your sequence.
N is the largest or last?
It's gonna be the same thing.
Oh.
Yeah, because if you're like, well, if it was one where we're subtracting, it actually might be the smallest number if our sequence is going down. So it's gonna be the last, you're right. So if I was adding them and it's getting bigger, it's gonna be the largest number, but say I'm subtracting by a common difference, it could be the smallest number. So I should change this, it should say the last number. So it's, the value in n is the last number. Okay, so yeah, because if my common difference was negative and I was going down, my last number won't necessarily be my largest. Okay, so then let's go ahead, let's just practice using this formula, just using these numbers that we have up here. Okay, so we already figured out that it's gonna be 35, but let's double check and make sure our formula actually works out for us. So I have this formula, so S of n is equal to my n times A1 plus AN over 2. Okay, so here's my sequence. I have the 1, the 4, the 7, the 10, the 13. What's my n number I'm gonna plug in? Paige, what do you think? Yeah, my n. Yeah, 5. I have 5 numbers. So 1, 2, 3, 4, 5. 5 numbers. So I would plug in a 5 for my n. Then Cooper, what do you think my A1 is going to be?
3.
3. Where'd you pull a 3 from?
Isn't it plus 3? Is that
Oh, because we're going up by 3. So our common difference would be 3. So my A1, I just need the first number.
oh, so 1.
Yep, just 1. So actually, when we're figuring out the sum, we don't use the common difference, the d, at all. So we use that back when we're writing the equations for sequences. But for series, we kind of, instead of using the d, we now use the n. So the n is the number of terms, okay? So the A1 is 1. And then Caden, what's my AN gonna be? So if I'm looking at these terms, so 1, 4, 7, 10, 13. 13, yep. So you just do your first one and your last one. Okay, so we do 1 plus 13 divided by 2. So then if I go ahead and solve this, Haley Winter, go ahead and walk me through it.
Add line 13,
Okay,
multiply that by 5.
okay, which will give me,
70
okay,
divided by 2,
which gives me,
35.
and then we can see that that's the same thing that we got before. Okay, so this equation worked out for us. Okay, so if you have like a really, really long sequence and you don't want to type all those numbers into your calculator, I would definitely just use that equation, okay? All right, guys, we will stop there. There's only like 2 or 3 slides left, so we'll finish that up tomorrow. And then you'll have work time at the end tomorrow and then Thursday as well, but we'll go over the quiz on Thursday, okay? All right, online people, how are we doing today? Questions, concerns, anything? Oh, also one quick announcement. Those of you who signed up for my Flex C today, I have a senior meeting, so you guys need to sign up for somewhere else Flex C. So none of you are seniors, so none of them you can come to my Flex C today, okay? So, because I have seniors today. So make sure you get signed up for somewhere, because I did kick you all out. So if you were signed up for me, I booted you out.
We can start in the beginning, we can do it during lunch too. Wire during What? Wire during Oh, darn.
Somebody can keep it or you can throw it away. It doesn't make a difference to me.
This is Merriman. Can I look at my quiz or not?
I'm not done. I'm like
Oh.
only like 2 pages out of 3.
Oh, do you want your
Oh,
phone?
yeah, we